All right, we are going to solve some quadratics. Look at this panda bear. After just looking at him, I think that in my next life, I'm coming back as a panda bear. Doesn't that just look like fun? Here I am. Okay, I'm adorable. Everybody loves me, and I'm doing nothing. That's my life. Okay, we are going to solve using whatever method we want. So the question is, what method should we use? First of all, the quadratic formula, this one will always work. Always works, okay? You can solve any, that actually is the world's worst writing, isn't it? You can solve any quadratic using the quadratic formula. Remember, a quadratic has to be in the form ax squared plus bx plus c equals 0. The method to solve quadratics by square rooting only works when you only see one variable. Okay, over here you've got an x squared, you've got an x. There are two variables. Over here you're going to have something that looks like x squared equals 25, or you're going to have x plus 5 squared equals 25. There is only one variable seen. Now there is another little guy that has not been brought back into the equation, and that is factoring. You can try factoring also. The question is what to use when, what to do, what to do, what to do. Oh, look at him. I'm just thinking what to do, what to do. I think that we shall call him Charlie the Panda Bear. Okay, so here's what's happening with my eyes. I am looking. There is one. I was going to make an arrow, but then I stopped at a one variable term. So what I'm going to do when I see one variable term is get the variable term alone. So is the alone, come on, right, it's not writing them. Is variable term alone? Yes, it is. Then we're going to square root, and you're going to remember the plus or minus, okay? So I've got square root equals plus or minus square root. I'm taking the square root of x squared, and I'm taking the square root of 16. The square and the square root cancel. I have x plus or minus the square root of 16 is 4. Bada bing, bada boom. Again, you can only use that when there's only one variable term. One variable term. I got three terms, but only one of them has a variable. So I'm going to move this 62 over to the other side. So now I have 2x squared equals 72. You might be inclined to start putting little square root signs. Do not do it. Do not, do not, do not. You need to divide everything by 2. The only thing that can be over there is the squared part. So equals 36. One variable term plus or minus the constant term. So I have x squared equals plus or minus 36. The square and the square root cancel. Square root of 36 is 6. I like those. Those are bada bing, bada boomers. Now this one you might think, oh my gosh, I've got to multiply x minus 3 times x minus 3. I'm going to get x squared minus 6x plus 9. Then I got to bring the 4 over by subtracting. So I get x squared plus 6, 7. No, don't do all that, guys. How many variable terms do you see? One. One little x. Is the square alone? I said the variable term alone, but I kind of lied. Is the squared thing alone? It is. If it is, then to unsquare something, we're going to square root it. So put your little square root signs there. This is x minus 3 squared. This is 4. The square and the square root cancel. You have x minus 3. The square root of 4 is 2. Now, last time we stopped there because that was x equals. But this time it's x minus 3 equals. So I have to add 3 to both sides. The negative 3 and the 3 cancel. Bada bing, bada boom right there, huh? Over here, I'm going to sneak that positive 3 in front. Then I'm going to put the plus or minus 2. And the reason I'm going to do that, remember, is with a plus or minus, I need to do two roads. I need to do the positive road, 3 plus 2, and I need to do the negative road, 3 minus 2. So I get my two answers. Okay, once again, got the squared term. There's only one variable, but that 4 is not part of the square, so I'm going to divide both sides by 4. I have x plus 2 quantity squared equals 20. One squared term, or one variable term, sorry. I'm looking at the little guy and thinking, I really do think I could be a panda bear. You just kind of go ba-da-doom, ba-da-doom, and everybody loves you. Wouldn't it be fun to have a life where everybody loves you? Oh, so wonderful. All right, here we go. Square and square root cancel. X plus 2 is plus or minus. There is no square root of 20. So this time I'm kind of perplexed. Ooh, I'm perplexed. I'm going to go off to the side though. Here I am off to the side, and I am going to simplify the square root of 20, and I'm going to do that by hedging. Remember, I divide by 2, 3, 5, 7. Commit to the same number until it stops working. I have a pair of 2's, so I'm going to bring out a 2. So when I go back over here, I have x plus 2 equals plus or minus, bring out the big 2, square root of 5. Now this one's a little rough, guys. When you subtract 2, your little mind's eye is going to say, oh, look, the 2 and the 2 cancel. Do not do that. Remember, the negative 2 sneaks in front of the plus or minus, and then you have 2 square roots of 5. This is your final answer. I can't put together a number that's rational, which means there's no square root, with a number that's irrational, which means there is a square root. So I just leave my answer that way. If I wanted to separate it, it'd be negative 2 plus 2 times the square root of 5, and negative 2 minus 2 times the square root of 5. But usually we're too lazy to do that. We're lazy like a panda bear. I need to Google. Do you think pandas are lazy? Dun, 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 dun. Okay, life is now changing because I see a p squared and a p. So there are 2 variable terms. If there are 2 variable terms, I cannot do, what just happened to my terms? Look at this, guys. Are you watching this? It's erasing as I'm writing it. What is going on? Oh, so weird. 2 variable terms. If there are 2 variable terms, I cannot square root it. I have to either do the quadratic formula or I can try oh my gosh, this is really weird how this is working. Factoring. Now, if I factor this, I'm looking for the factors of negative 3 that add up to negative 1. There are none, so factoring is off the table. So I'm going to do the quadratic formula. A, the coefficient of the squared term is 1. B, the coefficient of the regular old linear, it's called linear term, the variable that doesn't have an exponent, is negative 1, which makes the opposite of B 1, and C is negative 3. I'm also going to do the discriminant, b squared minus 4ac. So negative 1 squared minus 4 times 1 times negative 3. Negative 1 squared is 1. 4 times 1 is 4 times negative 3. Negative 4 times negative 3 is positive 12, so this equals 13. So when I go to the quadratic formula, p is equal to the opposite of b plus or minus the square root of the value of the discriminant all over 2 times a. So I get 1 plus or minus, 2 times 1 is 2. The question is there a square root of 13? The answer is no, it cannot be simplified because 13 is a prime number. So that is your answer. I knew it was going to be ugly because if you can't factor it, you're going to have a radical left in your answer. Oh, that is too precious. I just love that. Okay, the secret word is panda bears is cute. Panda bears is cute. Okay, I got 2 variable terms. I've got an x squared and an x. That means I need to bring that negative 1 over because remember, it has to be ax squared plus bx plus c equals 0. So I'm going to have 5x squared plus 5x plus 1 equals 0. I kind of cheated. I just brought it over in my head. So I could try factoring again. Multiply 5 times 1, I get 5. I'm looking for 5. That doesn't work. So I'm going to say a is 5, b is 5. The opposite of b is negative 5. C is 1. I'm going to find the value of the discriminant, b squared minus 4ac. So 5 squared minus 4 times 5 times 1. 25 minus 4 times 5 is 20 times 1. 25 minus 20 is 5. Oh my goodness, how many 5s can we put in one problem? So when I go to the quadratic formula, x is going to equal the opposite of b plus or minus the square root of the discriminant, which is 5, all over 2 times a, which is 5. So it's going to equal -5 plus or minus 2 times 5 is 10. The question is there a square root of 5? The answer is no. It is a prime number, so it cannot be hedged. So your answer is -5 plus or minus the square root of 5 all over 10. Remember, if you were trying to graph those, you'd have to use your calculator and get a decimal approximation. Okay, this guy says, peace out, babe, I'm done. No, look at he says, I was trying to leave, but look, this problem looks so interesting. I am going to bring the 6x and the 2 over because I like my x squared term to be positive. So I'm going to have x squared minus 6x minus 2 equals 0. If I tried factoring, it would be the factors of -2 that add up to -6. There are none. So we're going to go to the quadratic formula. A, the coefficient of the x squared term is 1. It's called the quadratic term. B, the coefficient of the x term called the linear term is -6. Opposite of B is 6. C is -2. We're also going to find the value of the discriminant, b squared minus 4ac. -6 squared minus 4 times 1 times -2. Now guys, are you listening? Guys, if you go to your calculator to do this, you must use these parentheses, okay? Otherwise, you're going to get the wrong answer. So -6 squared is -6 times -6, which is 36, minus 4 times 1 is 4 times -2. 36, -4 times -2 is +8, giving me a discriminant value of 44. So x is going to equal the opposite of b, which is 6, plus or minus the square root of the discriminant, which is 44, all over 2 times a, which is 1. So I have the 6, I have the plus or minus, 2 times 1 is 2. The question of the day is, does the square root of 44 simplify? And the answer is, let's find out. Okay, last time they were prime numbers, so we didn't even try. This time it's not. Divide it by 2, I get 22. Divide it by 2, I get 11. 11 is prime. I divide by 11, I get 1. I have a pair of 2's. So I'm going to bring out a 2, multiply 11 times 1, and get 11. At this point, you cannot stop. You have to look at all of the outside numbers. 6, 2, and 2. Do they all divide by the same thing? Yep, they sure do, guys. They all divide by 2. So we're going to divide them all by 2. So 6 divided by 2 is 3, plus or minus. 2 divided by 2 is 1, so I don't need to write it down. Square root of 11. All over 2 divided by 2 is 1. Because the 1's on the bottom, we're going to rewrite it as just 3 plus or minus the square root of 11. Holy moly, that screen is full. I think I should go eat. I bet that's what the panda's. Oh my gosh, he is. He picked up some grass to eat. I am psychic. I just feel like after something hard, you should always have a snack. All right, I got an x squared. I got an x. I got a 12 on the wrong side, so I'm going to bring it over by subtracting 12. I have 2x squared minus 8x minus 12 equals 0. All right, I'm really tempted to tell you a secret right now, but I'm not going to tell you yet. If we were going to factor it, we would multiply 2 times -12, which is -24, looking for the factors of -8. Ooh, I don't know about that. 1 and 24, nope, that subtracts to be 23. 2 and 12, nope, that subtracts to be 10. 3 and 8, that's 5, 4, and 6. Oh, I thought it might work. It does not. So, A is the coefficient of the quadratic term, the x squared, which is 2. B is the coefficient of the linear term, -8. Opposite of B is 8. C is the constant, -12. The discriminant, b squared minus 4ac. -8 squared minus 4 times 2 times -12. Again, use your parentheses. 64 minus 8 times -12. 64 plus 96. Oh my gosh, that is 160. You know what, guys? I'm not 100% sure I did that right. So I'm going to take a little time out here, go to a calculator, and put that stuff in there. It is right. Okay, I just didn't feel confident. So x is going to equal the opposite of b, which is 8, plus or minus the square root of the discriminant, 160, all over 2 times 2. So this is 8 plus or minus 2 times 2 is 4. Is there a square root of 160? Let's hedge it and find out. Divided by 2 is 80. Divided by 2 is 40. Divided by 2 is 20. Divided by 2 is 10. Divided by 2 is 5. Divided by 5 is 1. So it's not a perfect square, but it can be simplified, correct? So 2 times 2 is 4. Everything inside the 2 and the 5 is 10. Don't stop. Can the outside numbers all be divided by the same thing? Yep, yep, yep. They can all be divided by 4. So we're going to divide all 3 of those by 4. 8 divided by 2 is 4, plus or minus 4 divided by 4 is 1. Square root of 10, you don't touch the inside number. 4 divided by 4 is 1. Clean that up. 2 plus or minus, you don't need the 1, so you're just going to put square root of 10, and you don't need the 1 on the bottom. Now, there is something that I can tell you here. This is something I hate to tell you, but because you have an equal sign, you can divide every term by 2. So you know how over here we said do all the outside numbers divide by the same thing? Here we're saying do all of these numbers divide by the same thing. They all divide by 2. So if I take this, I could do 2x squared minus 8x minus 12 equals 0, and I could divide every single one of them by 2, and I would get x squared minus 4x minus 6 equals 0, and then I'm just working with smaller numbers. Now I'm going to tell you that's an old person thing to do, because us old folks did not have calculators, so we had to work with the smaller numbers that we could do. But it's doable. It's going to help you in Algebra 2. When you get to projectiles. Oh, look at, oh my goodness, there's more. There's more. Charlie says there's more. Remember, we named him Charlie. Okay, subtract 20. So I have x squared plus 8x minus 20 equals 0. Are there factors of negative 20 that add up to 8? 1 and 20. Oh, 2 and 10. I actually could do this one using negative 2 and positive 10. So let's look at that. Go back to factoring. X squared minus 2x plus 10x minus 20 equals 0. Remember how we factor with grouping? We're going to take an x out of both of these. So we have x times x minus 2. Out of both of these, we're going to take a 10. So plus 10 times x minus 2. Don't lose your equal 0. What do these two have in common? X minus 2. What's my leftover? X plus 10 equals 0. And then remember, we have x minus 2 equals 0. Add 2 to both sides. X is 2. X plus 10 equals 0. Add negative 10 to both sides. X equals negative 10. Now, I'm going to be honest. Most of you aren't even going to try that. But if I go back to x squared plus 8x minus 20 equals 0, and I do the quadratic formula, let's see, that's not A, look at that, I'm talking, A is 1. Let's see if we get the same thing when we do the quadratic formula. So my discriminant is b squared minus 4ac, so 8 squared minus 4 times 1 times negative 20, 64 minus 4 times negative 20, 64 plus 80 is 144. That's my hint that I know it's going to factor because that's a perfect square. So x is going to equal negative 8 plus or minus the square root of 144, all divided by 2 times 1. So that's negative 8 plus or minus, is there a square root of 144? It is 12. So I have negative 8 plus 12 over 2. That is 4 over 2. I get x equals 2. Look at that. I have negative 8 minus 12 over 2. That's negative 20 over 2. I get negative 10. Now, both ways work. It only works because it's ax squared plus bx plus c. and the factoring worked. Not everything factors. The last ones didn't. But it's a good thing to try. What a fun slide to end on, because I'm guessing the next is a checkpoint. And it shows you all of it. Oh, it's not a checkpoint. Look at, he's laughing at me. Ha ha, you messed up. It's not a checkpoint. All right, fine, I'll add 5. So now I have x squared minus 4x plus 5 equals 0. Ooh, are there factors of 5 that add up to -4? You might say, yeah, 5, -5 and 1, but the answer is no, because -5 times 1 gives you -5, not +5. So it doesn't work. Doggone it! So A is 1, B is -4, opposite of B is 4, C is 5. The discriminant, b squared minus 4ac, -4 squared minus 4 times 1 times 5. 16 minus 4 times 5, 16 minus 20, I get -4. So I say x is equal to 4 plus or minus the square root of the discriminant all over 2 times 1. Why are we getting that obnoxious sound? Can you take the square root of a negative number? No. So this one has no real solution. Okay. Now I'm going to do a little recap here. I'd like you to write this down. Those of you that watch these videos are going to be a huge advantage. Here's the deal. When you do b squared minus 4ac, if you get colon, a negative number, your answer will always be no solution. Okay? If you get a positive number, your answer will always be 2 solutions. Okay? Could have a square root, might not, but if you look at everything we've done, we got 2 solutions when we had a positive number. We have not done this one, I don't think, but if you get 0, so if you end up with the square root of 0, you only get 1 solution, because what's happening is, let's pretend this was that one. You'd have this 4 plus or minus the square root of 0 all over 2. Well, the square root of 0 is 0 all over 2. So 4 plus 0 is 4, 4 minus 0 is 4, so you only get 1 solution. This is just one of those cool little things that the SAT people actually like. How many solutions will you get? Okay, that's fun stuff. This was kind of a long video, but the pandas were cute enough to look at. So there you go, guys. How do you do it? How many times? How many variables? Blah, blah, blah. Shut up, Mrs. Evans. Just get to work. Hit the stop button. Okay, bye.